The method of group averages can also be used to find out equations of best fit curves, one of which is quadratic function for parabolic curves. Learn about it here in numerical solutions to CE problems. Given 10 data points, it is required to look for the best fit quadratic curve using method of group averages. In this example, there is no specific condition besides working on creating the simplest second equation. The quadratic equation we are talking about is y as ax squared plus b of x plus c. This is considered as equation 1. With a, b, and c as unknowns, we are to look for at least 3 equations. The second equation is to be generated using the simplest transformation. In the dataset, we take x as 1 and y as 5.68. Plug these into the quadratic equation and get 5.68 as equal to a by 1 squared plus b times 1 plus c. Now let's start eliminating the unknown variable c by using the method of elimination. Subtract equation 2 from 1, so c's cancel out. Then we get y minus 5.68 on the left. The right portion has ax squared minus a1 squared. Factor a and get a times x squared minus 1 squared. For the next term, we have b times x minus b times 1. Also factor b to have b times x minus 1. From the resulting equation, the quantity with a is the difference of two squares which are to be expanded. The expansion then makes the equation into y minus 5.68 as equal to a times x plus 1 and x minus 1 plus b times x minus 1. This time, factor x minus 1 and get y minus 5.68 as equal to the factor x less 1 multiplied by a times x plus 1 plus b. Divide everything by the factor x minus 1 to get y minus 5.68 over x minus 1 as equal to a times x plus 1 plus b. The left expression is then considered as capital Y, which is equated to a times capital X plus b, the same linear format we used in determining the best fit line. Now let's deal with the dataset. The same procedure is done as this still works on grouped averages. Divide the dataset into 2, and with 10 data points, we consider 5 data points on each group. Since the linear equation is now using capital Y as a times capital X plus b, add 2 more columns on each table. These are the columns for capital X, which we computed as x plus 1, and capital Y, which is equal to y minus 5.68 upon x minus 1. Fill out the capital X column first. If x is 1, capital X is 1 plus 1, which is 2. At x equal to 1.1, capital X is 2.1. With x as 1.2, capital X is 2.2. If x is 1.3, capital X is 2.3. Then, if x is 1.4, capital X is 2.4. Add all capital X's together to get 11. Then divide 11 by 5 to have 2.2. For the capital Y column, we have a longer expression, where we start with 5.68 minus 5.68 all over 1 minus 1, which makes 0 upon 0, and that is indeterminate. but in this procedure, we would take this as 0. The second y is then solved as 8.05 minus 5.68 all over 1.1 minus 1, giving 2.37 over 0.1. This is then equal to 23.7. The third y is then solved as 10.25 minus 5.68, and the answer is divided by 1.2 minus 1, which gives 4.57 all upon 0.2, simplified as 22.85. The fourth capital Y follows the same pattern, so take 11.97 minus 5.68 all over 1.3 minus 1, which gives 6.29 over 0.3, simplified as 20.9667. The fifth capital Y is then 12.68 minus 5.68 upon 1.4 minus 1, which is 7 over 0.4, or that is 17.5. Having completed the column for capital Y, add all y's to get 85.0167. Then divide this by 5 to have 17.0033. With the two averages already determined, we can generate the third equation as 17.0033 as equal to 2.2a plus b. Do the same for the second group from x of 1.5 to 1.9. The first capital X is taken as 2.5, the second is 2.6, the third follows similarly as 2.7, then 2.8, and last is 2.9. Add all these together to get 13.5, then divide 13.5 by 5 to have 2.7. For the capital Y column, at x of 1.5, capital Y is then solved as 16.7. The second y is taken as 16.3. The exact figure for the third capital Y is 114 over 7. The fourth is 16.05, and the fifth capital Y is 709 upon 45. The summation of these values is 81.0913, the average of which makes 16.2083. For both averages, the fourth equation is written as 16.2083 as equal to 2.7a plus b. By the method of elimination, we subtract equation 3 from equation 4. That would give 16.2083 minus 17.0033 as negative 0.795. Then 2.7 minus 2.2 gives 0.5a. A is then solved as negative 1.59. Replace a as negative 1.59 in equation 3, making 17.0033 as 2.2 times negative 1.59 plus b. So b is then 20.5013. Again, plug a and b values in the second equation and get 5.68 as equal to negative 1.59 times 1 squared plus 20.5013 times 1 plus c, where c is solved as negative 13.2313. Knowing all variables, we write the quadratic equation as negative 1.59x squared plus 20.5013x minus 13.2313. Another case from the same dataset is to find the best fit quadratic curve which passes through point 1.5, 14.03. Again, take equation 1 as the quadratic equation itself. Then create equation 2 by using the coordinates 1.5, 14.03 into the equation, creating 14.03 as equal to a times 1.5 squared plus b times 1.5 plus c. Even without deriving, generate the expressions for both capital X and Y, where capital X is taken as x plus 1.5 and capital Y is y minus 14.03 all over x minus 1.5. Create the two groups for the method. The first group contains x as 1 to x as 1.4. The capital X values are from 2.5, 2.6, 2.7, 2.8, and 2.9 using the expression x plus 1.5. The total of capital X values is 13.5. Then divide this by 5 to take the average of 2.7. The capital Y values are solved through y minus 14.03 upon x minus 1.5. The first capital Y is 16.7. The second is 14.95. The third is 12.6, followed by 10.3, then by 13.5. Add all these capital Y values all together and get 68.05, which is then divided by 5 to get 13.61. From the first pair of averages, the third equation is then written as 13.61 as equal to 2.7a plus b. The second group has x values from 1.5 to 1.9 with their y counterparts. The capital X values are from 3, 3.1, 3.2, 3.3 until 3.4. The total of capital X values is 16. Then divide this by 5 to take the average of 3.2. Capital Y uses the same expression where at x of 1.5, capital Y is 0. This is the point under consideration where the expression will lead to indeterminacy, and 0 is considered instead. The other capital Y values are 14.3, 15.25, 14.9667, and 14.575. Add all of them together to get 59.0917. Then divide the summation by 5 to get 11.8183. After completing the table, we can write equation 4 as 11.8183 as equal to 3.2a plus b. Proceed to using the method of elimination and subtract equation 3 from equation 4 to eliminate b. 11.8183 minus 13.61 gives negative 1.8017. Then 3.2 minus 2.7 is 0.5a. A is then solved as negative 3.6034. With a known, plug this into equation 3, which makes 13.61 as equal to 2.7 times negative 3.6034 plus b. B is then solved as 23.3392. Substitute a and b into equation 2 to have 14.03 as equal to negative 3.6034 times 1.5 squared plus 23.3392 times 1.5 plus c. C is then computed as negative 12.8712. With all variables known, y is then negative 3.6034 x squared plus 23.3392 x minus 12.8712. If we compare this equation from the previously solved, there is a great difference by merely choosing a different point for equation 3.